They are both working in the Amazon, applying multidisciplinary and participatory approaches in their research. So thank you very much for sharing your works and the research with us today. So briefly introducing them, Paul van Damme is a Belgian biologist and environmental scientist specialized in aquatic ecology, fisheries, and biodiversity conservation. He is currently the technical director of the Faunagua NGO in Bolivia, where he has been working for many years on applied research and conservation projects. His work focuses on fisheries management and conservation of aquatic species, often in close collaboration with local communities. Then we have our second speaker here, which is Camilla Usai, who recently graduated at the University of Trento in the Master of Environmental Engineering for International Cooperation. And she carried out her research thesis within the Talete program and the NANE project in the Colombian Amazon trapezium. So before we begin, just a couple of practical notes. Each presentation will last about 20-25 minutes, and questions and discussion will follow at the end of the two presentations. So we have people joining both online and in person. For the people who are joining online, just a quick reminder that the seminar is being recorded. So if you prefer to not appear in the recording, feel free to turn off your camera. So let's get started. Paul, the floor is yours. And yeah, I will leave you the sharing of the screen.
Okay, good morning. Can you see my screen? Hello?
Yes, yes, we can
Can you
see you.
see?
Yes.
You can see my screen. You can start. Okay.
Yeah.
So let's start. Good afternoon. So I'm Paul van Dam. I will give you a short seminar on, which has as a title, Chronicle of an Almost Extinction for Tools and Mitigation Strategies. And I will introduce the case of the gilded catfish, which is a large catfish which we have in the Bolivian Amazon. This work is in cooperation with Fabrice Duponchel, which is a Frenchman working with the Institute for Research and Development in France. And we also work very actively with two fishermen, which are Omar Ortuño and Johnny Mendoza, fishermen from Puerto Villajuel in the Bolivian Amazon. Actually, most of this work is supported by Aguas Amazonicas, which is an alliance in the Amazon between researchers of 5 countries. Actually, I just would like to tell you a story. So I start my seminar with a story, which is the story of Yuru and Ara. This story actually is written by an Italian writer, an Italian illustrator, which is called Eva Lucia Baiari. And this story was published in 2010, which is actually already 6 years ago, but it's very up to date. So I want to present you shortly this story, which is about a parrot which meets a male gilded catfish in the Ichilo River, which is in an Amazon headwater river in Bolivia. And the parrot asks to the gilded catfish, where do you come from? So the catfish recounts on the period when he lived in the estuary of the Amazon River, and he answers, every year when the rain season comes, the river rises. The water brings and carries food and seeds to the main stream. We can sense these changes in the water temperature and sediments when it gets to the river mouth. This is our sign to swim upstream to spawn. And then the parrot asks, what are you doing here alone in the river, in the upstream river of the Ichilo? And the catfish answers, I made it to these fastest waters of the Chilo River. My swimming skills are challenged up here. It is the perfect beginning of a life trip for my offspring. My offspring will have to travel from the Ichilo and Mamoré rivers in Bolivia to the Madeira and Amazon rivers in Brazil, a trip which takes them from the Andes to the Atlantic Ocean. And I was supposed to find a female Dorado here. I was supposed to fertilize her eggs. But perhaps I've misunderstood the river message. And then with the parrot, they come to an agreement, and the parrot flies downstream to find a female gilded catfish. And there downstream, she meets a fisherman whom she asks for support. And the fisherman captures a female gilded catfish, keeps it alive, returns it to the river after explaining to the female that a male gilded catfish is waiting upstream for her. And then the female swims upstream to meet the male, and they make love. And the parrots watching all this see the eggs in the water, and later the little fish floating downstream along the Mamoré River. And actually the book ends with the fifth slide here. This was the last brood that the Ichilo would bring. That's how finishes this text. And it's also interesting perhaps to mention here at the right that the fisherman afterwards takes part of an assembly, of a meeting with public stakeholders in which he reports on the lack of catfish in this river. And the book ends with telling that the fisherman was able to express his concern and received answers from the public authorities. So actually this book is published in 2020, 6 years ago, and it's very up to date because now it's very applied in the Amazon where we are working. So I go on with my story, which is a different story, but very similar to the story of this Italian illustrator. First, I wanted to present you very shortly the Amazon, which you for sure know very well. The Amazon is a fluvial system globally. It's the largest one. Its waters originate in the Andes Mountains, and these waters flow to the Atlantic Ocean, more or less 5,000 to 6,000 kilometers downstream. Part of this water, of course, evaporates and returns to the headwaters in the form of clouds, also called air streams. Now, the Amazon is home of an incredible biodiversity. There are more or less 2,500 species of fish living in the Amazon. And it's also home to an extraordinary diversity of aquatic mammals, such as here the Amazon river dolphin and the giant otter. No? It also sustains the life of 46 million of peoples whose livelihoods depend on this river. Among these, there are 350 indigenous groups living in the Amazon. Now, people have evolved with the Amazon during thousands of years, and their livelihoods strongly depend on the Amazon, especially the livelihoods from fishermen who live from catching fish in this river. Now, our work is in the Moxos lowlands here within the red circle below, which is located in the Bolivian Amazon and which is actually one of the largest wetlands in the world. It floods more or less 120,000 kilometers during the high floods between November and May. So this is a very important area in the Amazon system. Now, this high biodiversity in the Amazon is actually explained by the high habitat biodiversity. Also, it's explained by the connectivity with the Andes Mountains and by the consequent hydrological regime, which is characterized by high seasonality. Within the Amazon, we actually have different types of fish species. The most important are these catchfish species, amongst which we have the long-distance migrating species such as the Dorado, of which I will talk more afterwards. And then also we have a lot of heracid species, such as this species here, which is the pacu, which is a fruit-eating species which enters in the floodplain during the inundation. Now, the annual production of of fish in the Amazon is very high. No, more or less, we estimate that the annual production of fish used by fishermen is 173,000 tons. So I want to go now into a bit more detail on the biology of the long-distance migrating catfish. The long-distance migrating catfish belong to the genus Brachyplatystoma. And perhaps we could say that they are the most emblematic species of the Amazon. And during this seminar, in particular, I will deal with the most astonishing one, this one, the Brachyplatystoma rusiosi, which is called also gilded catfish in English, or dorado in Spanish. These species actually use the entire Amazon system along their life cycle. They undertake incredible migrations of thousands of kilometers, much longer than whatever other species in fresh water. Most of these species migrate between thousands to 20,000, to 12,000 kilometers. Other species, such as the surubee, for example, this one here, migrates shorter distances, more or less between 500 and 1,000 kilometers. So these species are the most incredible migrating species in the Amazon. Now, as I told you, I will focus mostly on the gilded catfish, which is a species which actually migrates the longest distances. This species spawns in the upper streams of the Amazon, and the larvae of these species float downstream more or less between 4,000 and 5 kilometers downstream to the estuary. So they cross the Madeira River here, they enter the Amazon River and arrive at the estuary after 2 years. And then afterwards they will stay here during 2 years and will grow till feeling the need to return to the Madeira River and spawn here. So this species is characterized by an exceptional life cycle, traveling downstream 500 kilometers and afterwards upstream again 5,000 kilometers. As I told you, it's the longest distance migration known in fresh water, more or less 10,000 kilometers. On the photos, you can see here an adult gilded catfish, which we found in Porto Vilajoel, which is located here. And then here the small 2 years old gilded catfish, which are very common in the estuary of the Atlantic Ocean, of the Amazon River. Now, you could ask how did we identify these incredible migration patterns of this species? The most impressive method was actually the microchemistry of the otoliths of this species. Otoliths are the air stones which can be found in the head of the gilded catfish. So this question of natal homing and long distance migration was investigated by the analysis of 2 isotopes of strontium in the Amazon waters and in the otoliths of the fish. The profile of these isotopes, or with other words, the relation between the concentration of the 2 isotopes is different in the Amazon, as you can see here in blue, and in the Madeira River. And then because these isotopes accumulate in the otoliths of the fish, the relative concentration in the otoliths can be used to trace the migration patterns of the fish traveling between the 2 river systems. Or actually the quantitative analysis of the isotopes of strontium in the otoliths can be used to deduce the habitat and the migration of the dorado of a given size or age throughout their life cycle. So actually we can use the strontium, also isotypes in the otoliths as a kind of memory, a kind of disk drive, a type of geographical image to trace migration patterns by each individual. You can see this, for example, here. This is a strontium profile for fish which have been born, which were born in the Madeira River. So they have a Madeira profile, then migrate to the Amazon, and then they return to the Madeira to spawn. So reading this profile, this strontium profile in the otolite, we can reconstruct migration pattern of the fish. So one main question stayed after doing this analysis, which was whether these fish also show natal homing, which is also called philopatry. And Fabrice Dupochel, the guy with which we have worked, a French guy, has actually published already in 2016 an article in which he demonstrated that these fish which spawn in the upper river and which go to the estuary of the Amazon River come back and execute or do actually natal homing. They are philopatric species. So this has been proved using these strontium isotopes in the otolites. So this question has been resolved already in 2016. So for all these individuals, we found actually a profile for strontium with fish that were born in the Madeira. They traveled to the Amazon basin. They arrived at estuary and came back to the Madeira to spawn. So then we analyzed very much individuals, and we found actually that 78% of these individuals were philopatric. So they were showing this typical pattern of fish migrating 10,000 to 12,000 kilometers. So what happened then afterwards in 2019? These studies were actually done based on samples taken before 2009. In 2009, something happened in the Madeira River because Brazil decided to construct 2 hydroelectric dams in the Madeira. The construction of these dams took 6 years. They started in 2009 and they were finished in 2015. The first one was Sant Antonio, which is a dam very close to Porto Velho. And then upstream of this dam, they constructed the Girau Dam, very close to the Bolivian border, which was finished, the construction in 2000, more or less 2013 to 2015. These dams were, as I told you, constructed between the border with Bolivia, which we have more or less here, and Porto Velho, which is more or less here. These dams are actually barriers for the adult gilded catfish, which means that these catfish, the adult ones, the pre-adult ones, cannot overcome the swimming up. They cannot overcome the barriers. They cannot swim anymore upstream to the Bolivian headwaters. So they're actually blocked downstream for the dams. But it's also important to mention that a small percentage of the larvae which drift downstream can pass these dams, more or less 10%. We don't know actually how much, but we suppose that more or less 10% of the larvae of this fish which float downstream can pass these barriers and finally arrive in the estuary. So what we actually did to what happened with the gilded catfish was set up a participatory fish monitoring system, which is actually a kind of tool which can be used to obtain long-term biological series and also at the same time promote inclusive conservation. So we set up the system with a lot of fishermen which worked with us between 1998 and 2025, during 25 years, in the upper Amazon River, which is here, an headwater in Bolivia. And they filled forms during 2 periods of 10 years, before the construction of the dams and after the construction of the dams. So we worked with them. Here you can see in an infograph how they worked. They worked between 98 and 2009, which were actually the parents, the fathers of the fishermen with whom we work now, which have been registering their catch, which you can see here, the catch of different species before the construction of the dams. And at the right, you can see how the sons of these fishermen did the same after 2015. So also registering all the fish catch in forms which are shown here. And this allowed us actually to see what happened with all the fish species after the construction of the dam. And this was published in an article which is now in press, which has as title Disentangling Dam Impacts, Hydrological Regime and Fisheries Effort on Fish Catches in a Bolivian Headwater Using Citizen Science. And these are the results. I will not go into much detail because we don't have a lot of time, but for most of the species, there were not many. Of course, we have a lot of fluctuations, which were correlated with the inundation patterns, which we recorded also in the same area. High inundation peaks in general coincided with high capture peaks. No? I will not go into detail, but I will only show that for one species there was a very strong exception, which is for the Dorado. For the Dorado, we found a different tendency, a different trend. No? For this species, we found a complete decline. So the population density of Dorado fell to 1% of the population density which we recorded before the construction of the dams. So there was a clear indication using this type of monitoring that there was a specific decrease for this species. We also have shown this with different other methods and approaches. For example, here we show the catch per unit effort using a specific method, which are hooks, no? Or drums and lines provided with big hooks, which are used in the river channel of the Chilo River, in the upstream river. And we could show that before the construction of the dams, these hooks catched or caught actually a mixture of four species, four catfish species. And after the construction of the dams, only three species were present and the Dorado became absent. No, it disappeared from the captures, the catches of this method. So this was a very clear proof that using the same methods, standardized methods, the one specific species disappeared from the catches. Now this is the same graph actually, and this graph shows that after the construction of the dams, we still found some individuals. So which are these individuals? You can show here one of these individuals, which has been caught in Puerto Villarreal. These actually were the philopatric individuals, which were able to pass the dams before their construction, and then stayed upstream, spawning every year. But of course, these individuals, which have a maximum age of 16, 17 years, slowly got extinct. There's the individuals that have passed the dams before 2009 at an age of more or less 2 or 3 or 4 years. They could remain in the upper headwaters, spawning every year, but they died, all of them, before 2021 because their maximum age was 17 years. So these individuals slowly disappeared. So this we predicted also in an article which we published in 2019. So we predicted the extinction of this species in the year 2021, 2023, more or less, of all the individuals that had passed the dams before 2009. But then came up the question, what about some individuals which we caught after 2021? Because it was very strange. We still kept on finding from time to time new individuals, big individuals caught also in the same place. Actually, it's now very interesting because yesterday a fisherman sent me these two photos from fish which have been caught in the same area 2 days ago. It's very strange because that's the only individual which has been caught in Puerto Villarreal this year. And for sure it will be the only individual. So we asked ourselves, why are we still catching individuals from time to time, very little individuals, after 22 in the same river, although they had to be already extinct? So this question we have tried to answer again with microchemistry of otoliths. We try to see why we still have some individuals arriving at Puerto Villarreal. So we equipped actually local fishermen with all the material such that they could retrieve the otoliths of these remaining fish individuals. Along time work which we have done in Peru, in the upper Bolivian Amazon. So we got actually from them more or less the otoliths of 100 individuals. And the results of the microchemistry analysis has been published now in an article, which is now under review in Conservation Practice and Theory, which is an international journal, which reports the data on strontium analysis of the otoliths of these more or less 100 individuals. And at the same time, we have recorded if these individuals were had mature gonads, if they actually were reproducing individuals. So what did we found? No? First, we found that more or less 72% of these individuals, which we found upstream of the dams, actually were forced residents, individuals who were born in the Madeira and stayed all their life in the Madeira. So they did not arrive at the Amazon River, which is here, and they never arrived at the estuary. So the question was, what are these individuals? These individuals were actually the offspring, the young individuals, the offspring of old individuals who had spawned in the headwater in the previous years. And these offspring, these smaller individuals, stayed here upstream of the dams because they could not pass the dams, continuing their traveling downstream to the estuary. So these actually were the offspring of the individuals, of the big individuals, which had spawned here in Porto Vilajoa. And they got clocked here a lot of individuals upstream of the dams. Now, these are these individuals, the smaller individuals, and actually we found also that these individuals had a very low growth rate. They did not have a gonad development, could not reproduce, and had a low body condition, which is a bit explainable because they did not find enough food in this area to grow fast and to be able to reproduce afterwards. So these fish actually wanted to travel to the sea and did not learn to swim upstream, to spawn upstream, and to spawn there. So they actually kept on trying to swim downstream to the river. Now, besides the 72% of the individuals which we found, we also found that more or less 28%, 16 individuals of the samples were actually philopatric individuals. Very strange. No, actually, it were individuals who had left Porto Vilajoa as a larvae. They had passed the dams and they arrived at the estuary. After 2 years, they decided to come back and they got stuck here, very close to the Sant Antonio Dam. These individuals, which we found here in Porto Vilajoa, were actually individuals with developed gonads, and they were actually, and this is shown by this figure, exclusively old nettle homers or strolling individuals which were born in the Amazon, individuals which actually were born in Porto Vilajoa, arrived to the Amazon, arrived at the estuary, and then came back to Porto Vilajoa, which was actually not explainable because according to our theory, they could not have passed the Sant Antonio Dam swimming upstream because the dam, we know, blocked the upstream migration of these individuals. There was actually a question which we could not answer by this analysis. So then we also analyzed the age of these individuals. So we recorded the birth date of these individuals which have been caught here in 2021 or 2023. In this figure, we actually map the birth date and the return date to the Madeira to the right. To the left here, the birth date, and to the right, the return date to the Madeira. So actually what we found that from these 16 individuals, only 4 individuals could have returned to the Madeira before the start of the construction of the first dam, which are the blue ones. Only 4 individuals could have returned to the upstream river before the construction of the dams. And the 12 other ones, strangely, have passed the 2 dams, because the return date was later than the start of the construction of the 2 dams. So there was actually the same question which we could not answer. How can we observe profiles for strontium in the otoliths of philopatric individuals if the fish cannot cross the dams swimming upstream. So after a long time and a lot of discussion with the dams, we actually found that the dams had been translating manually individuals from downstream to the Bolivian Amazon. They have been translocating in total 300 individuals manually, thus not through the dams, not through the bypasses which they have, but which not function. They have captured them with fishermen downstream and have put them in the Bolivian Amazon, where these fish continued their migration into spawn in Portugal as well. So these 12 individuals were some of the individuals, some of the 300 individuals, which had been translocated by the dams close to the border of Bolivia. So these were actually some of these individuals, and these were the same individuals, taking up again the figure which I showed you before. These were actually individuals which we found in Portugal as well. Some of the big individuals which we are still finding in 2026. Some of the individuals which have been translocated manually by the dam company. So a summary of this, I don't know if I still have time. Before the dams, we actually had spawning individuals in the upstream sections of the Amazon with reproducing individuals, which traveled downstream as larvae, lived 2 years in the estuary, and then came back to spawn in the upstream river. After the construction of the dams, we had actually in let's say in 2018 or 2020, we had some old reproducing individuals which were slowly getting extinct. We had quite a lot of forced residents, upstream of the Jirau Dam. We had few larvae, more or less 10% of these larvae passing the dams downstream. And we had here fish in the estuary which decided to swim upstream, but could not continue their migration upstream because they were blocked by the Sant Antonio Dam over here. Also, these were natal homers, they could not arrive to Portugal as well. So now, at this moment in 2026, we have a quite different situation. This population of old reproducing individuals has got extinct, they are not anymore. We only have forced residents in Bolivia. And some of these fish, which were actually waiting here downstream of the dam, have been translocated by the dam companies to the Bolivian Amazon and then could afterwards swim to Puerto Villajuel and again spawn in Puerto Villajuel where we are working. Some reproducing animals, very few of them, which have been translocated manually. So this is more or less the scheme which we have reconstructed after a lot of work in the area. So now the question is, how can we mitigate all these dam impacts? Because we know now that the dams have a strong impact on the species. We made some conclusions. First is that the population residing in the Upper Madeira, which now largely constitutes the majority, is not reproducing. They are forced residents which do not learn to swim upstream to spawn. We know also that only fish that grew up in the estuary are capable of reproducing. We know now also know that in the upper reaches of the Madeira River, there are probably no more old specimens, which are the ones that managed to naturally migrate upstream of the dams before the closure of these dams. We also know that the very few individuals in the upper Madeira are individuals located by the Jirau company. So we also decided or concluded that manual translocation by the companies is working and is currently the only way to save the population of the gilded catfish of the upper Madeira River in the short term. So, and at the same time, we understand that the long-term survival of the species in the Madeira Basin requires much more international collaboration and effort among public stakeholders, fishers, businesses, companies, and the scientific community. So we think that what we have been doing is a nice example of how all these stakeholders have to work together to secure the long-term survival of this species. So of course, this process is already going on. We have now a short chronicle of actions for the conservation of the species. Here we show them very shortly. First, the Dorado has been already declared as vulnerable in Bolivia in 2009. Imagine the year of the start of construction. We also already declared the species as vulnerable. Then afterwards, the categorization of the species as vulnerable to extinction was done in 2023. Then in 2024, the species was included in the Appendix 2 of the Convention for Migratory Species. And then finally, in 2026, this year, in February, the Regional Action Plan for the Conservation of 2 migratory catfish species in the Amazon was endorsed by the COP during the COP15 of the Convention for Migratory Species. So there are already a lot of steps taken by different stakeholders to try to conserve this species. Also interesting to show, I think it's almost the last diapositive on the last slide, that our fishermen, the leading fishermen, which we have been working during 25 years, was invited to the COP. This is the same fisherman, which is shown here, was invited to the COP in Campo Grande in Brazil to give a presentation of what he has been studying together with the scientists during 25 years. So this was a very important moment last month in the COP15 in Campo Grande. So I think I have the impression that this perhaps pilot study is a nice exercise, a nice picture, a nice proof, let's say, on how we can combine scientific knowledge with traditional knowledge, with participatory monitoring, and use this information to do public advocacy and to have some incidents also in private companies to oblige them to translocate individuals in the Amazon. So I want to finish. I don't know if I've used all my time. I want to finish my presentation actually with the last page of this booklet, which I started my seminar, which actually says that the messages from the Mamoré River no longer reach the Amazon River mouth. The fish that attempted to swim upstream the Mamoré find the Madeira dikes, dams, and they do not succeed. River connectivity has been lost. The dams do not allow the fish to migrate or do not allow the flow of fish. Dams retain sediment and prevent flooding of the river at the plain. The last catfish captured in the Ichilo was in 2019. Now we understand it is when we can do something about it. That's the final message in the book which was published by the Italian illustrator. Thank you very much.
Thank you very much, Paul. Can you hear me? Okay. Thank you very much, Paul, for your presentation. Very inspiring and very interesting. Now, I remember questions, if you may have, will be done at the end of the second presentation. So now I will leave the floor to Camilla. And
Good afternoon, everybody. I hope you can hear me well. It is a pleasure to be here this afternoon. So I will talk to you about my thesis research that I did in the area of Leticia along the Amazon River in Colombia. and I will start by introducing to you the regional context and the study area, to then move on to the methodologies and the results. The aim of this research is to develop an integrated social, hydrological, and socio-geomorphological approach to analyze the dynamics of seasonal low-flow events along the Colombian Amazon River Reach and their impact on local indigenous communities. So this research integrates three different type of methodologies, which are hydrological analysis, remote sensing analysis, and a semi-qualitative research with the indigenous people. So the Amazon River Basin is the largest river basin in the world, and it expands approximately 7.8 million square kilometers. Its mean annual discharge, it's around 200,000 cubic meters per second. And to give you an idea of the amount of water, it's approximately 15 to 20% of the global river runoff that goes into the oceans. Then it is characterized by a bimodal hydrological regime, which alternates the high water seasonality that are to be found usually around April and May, with the low water seasonality that instead it is to be found around August and September. Also, we have a transboundary basin coordination governance that it's called Amazon Coordination Treaty Organization that coordinates the member states that are to be found across the Amazon River Basin, since they are 8 countries, and it was born in 1978. It aims to face some of the challenges that are to be found on the basin, such as deforestation, mining, the degradation of water quality, and so on. So the study area, it's in Leticia, in the river reach that goes between Leticia and Puerto Nariño. We are in the southern part of Colombia, in the Amazonas department. And the river reach that I studied, it's a portion that expands 75 kilometers. And it involved my project, indigenous people communities that are organized underneath 2 main organizations that are ASITAM and Aticoya. And the duration of my field trip that I did from October to December last year in 2025 had a duration of 3 months, and inserted inside the NANE project, which instead started in September 2025 and will have a duration of 3 years. And it regards indigenous territorial governance and climate resilience in general. So I did 17 semi-structured interviews on 4 different indigenous people communities, 2 to be found on the main river reach and 2 to be found on the tributaries. The age range of the people, it's around 30 to 75 years, with the people that I interviewed having different occupation, going from farmers to fishers, but also community leaders, for example. So I asked a question about the seasonality changes. So I also asked to draw the shorelines on georeferenced map of high and low water level, and having a focus on drought events. So asking the duration of the droughts, the intensity, and mainly the impact on the activities. Then I processed the data on QGIS, digitalizing the hand-drawn maps, and then georeferencing them there. Then I also used to make a quantitative aggregation of the data, Boolean matrices built from the answers mainly on the seasonality. Also, I took the hydrological data from IDEAM, which is the National Scientific Institute of Colombia, and I did a consistency check of the data. So analyze some trends, such as the general trends, such as the maximum and minimum daily discharge. Then I also analyzed some statistical trends that I will show you before, also analyzing some of the pattern of the missing data. Then taking the Sentinel-2 multispectral imageries from Google Earth Engine, I did a classification of the 3 main macro units, water, sediment, and vegetation, imposing an NDVI threshold of 0.4, and also imposing a cloud cover limitation of 20%. From here, I selected from the list of images available 10 low water images that were selected manually, comparing them with the days that had a minimum water level from the hydrological data, and obtained just one winter image in almost 10 years of data. This is due to the big cloud cover that it is to be found in this area. Then I analyzed, I did some analysis on QGIS of these images, going from a low water frequency map. Then I also studied the wetted area variation seasonally and interannually, as also taking an island to be found on this river reach, the Meccanica Island, and I studied the bank erosion and advancement of it. So when people were asked whether the seasonality of the river changed over time, 94% of the people said that they perceived that it did change. And the river was described as being physically larger and more powerful in the past. Also, it was underlined a loss of seasonal predictability, as also an intensification of extreme events with the focus on droughts. On this matter, 2024 was indicated as the most severe drought event by 82% of the respondents. And I also asked some question on the duration of droughts, and there's quite a good correspondence also with what we we can find on literature, as well as whether people perceive droughts being more intense, and 80% of the respondents that they perceive it as more intense than in their childhood. Also, I investigated the time that it takes for people to walk to the navigational point of the water. And the amount of time to be found in these answers, it's very different depending on where you can find the communities. So the impact of droughts find trade to be the most impacted area of the activities, followed by fishing and agriculture. But I also asked about the impacts on health, having diarrhea, for example, and malaria and dengue connected to unsanitized water for fever, especially for children, and bad quality water, and also stagnant water. Malaria and dengue were cited as a big problem. Then 80% of the respondents reported a change in their sense of safety over time, and 75% of these people perceive that they feel less safe due to the connection to drought severity that it is increasing. So here you can see that I analyzed the data availability. As you can see, all of the records show different gaps throughout the years, and all of the data available for all the station are water level data, and just 3 stations presents as well the discharge data. But Nazareth, it's the one that shows the longest record, and for this reason was used as a reference data station. So from the graph that I just showed you, I noticed that some of the missing gaps of the data were recurring seasonally. So as you can see on the graph on the bottoms, the blue bands comparing to different stations, one with continuous data and the other one with several gaps. I found out that, as you can see in the blue bands, these are the missing data periods that always coincides with the water levels. And this could be due to the fact that it's very difficult to study the level of the water in a kind of environment that increases and decreases its water levels during the winter time and summer times. So I studied the zeta scores and standardization signals, and we can see that it's coherent for all 6 stations, as also the percentile by station. And this gives a good, it says that the data are practically good and there is a good consistency between all of the stations. And this was a good base to go on with the analysis. Also, moving on to the relative monthly discharge contribution, here we can see that we have the peak contribution in May, April, and June, while the low water periods are to be found in September, October, and August. On this analysis, I did a man-candle test trend, which showed that September has a significant decreasing trend, which means that it gives a reduced contribution over time. So summer times it's becoming much more strong. The other months show no significant trends, and also, I analyzed the annual flow volume, where you can see the mean annual volume. It's approximately 1,110 cubic kilometers, where here I reconstructed also 2 different years, 2023 and 2024, that were indicated in the interviews and also in the literature as 2 of the strongest years with the drought events. As you can see, also here we are way below the mean annual volume. Then moving on, I did an annual maximum and minimum daily discharge I analyzed, and the maximum are usually to be found around May, and while the minimum values are to be found from September, October to August. Doing a man-candle test trend, here we see that there's no significant trend and there's no interesting thing to show you. So for the remote sensing, I present here the low flow water frequency map, where you can see where there's white, there's never waters, while as the water becomes more intense, there's a highest frequency of water being present. And we can see that overall there is an branching system where the main channel results to be more stable, while the secondary channels comes out to be more variable. Then here you can see the remote sensing and hydrological data compared, taking a high water image season from February 2021 and one from August 2021. And you can see that some of the sediment bars are exposed and there's a much higher water level drop. As you can see here, it's 7 meters, and the discharge also decreases a lot, as also the wetted area. And this comparison was also done for February 2021 with September 2024, that, as I told you before, it's the year with the strongest droughts that came out from the interviews. As you can see already visually from the image, the sediments are much more exposed compared to the one of 2021. And also here, the decrease of the water level and discharge, it's much higher than before. And we can see this also comparing to interannual low water season from August 2021 and September 2024, where we can see that there's a drop even between two summer periods, comparing, taking this 2024 strong drought event. And also here you can see the wetted area and discharge that I put in comparison, that shows a sort of rating curves that can also gives us information on the habitat of the river. Then I analyzed the Meccanica island that you can see in the map, and how the bank it's eroded or how it advanced. And the red part indicates the bank erosion, while the green part, it's the advancement. And even though you can see from the percentage that they seems to be very small numbers of erosion rate and advancement rate, if you see the same amount shown in the table on the left in hectares, you can see that we are talking about very big amounts of soil and sediments that are being eroded or are advancing, which shows that it has a big impact on the communities that lives nearby the island throughout it, from one year to the other. Also, I connected the bank erosion and advancement to the cumulative volume, which means to the amount of water that passes by from one year to the other. Also on the map on the right, you can see the island that changes from 2019 and 2024. As you can see, there is a movement that seems to be closing off the channel on the right, which could be it's already the narrowest channel, and might be that in the future it will be closed off due to this movement of the island. Then comparing the perception of past and present discharge from interviews with the hydrological data, here we can see I compared the mean monthly discharge with the perception of maximum and minimum water level, that are the dots on the image on the left, and the monthly difference of discharge, so taking from February to January, and the perception of increasing, decreasing water. And overall, what we can notice is that there's a good correspondence between what the indigenous people perceive and live throughout each year and what the hydrological data shows. These are instead the spatially explicit interviews that I that I digitalized on QGIS. And the red lines that you can see on the image on the top, it shows the shorelines that are drawn of the year of 2024, and they are put on the macro units of the Sentinel-2 image, and there we can see that there is a good correspondence and accuracy nearby the settlements of the communities, while as we go further away from the communities, due to the fact that we are talking about very big spaces and distances, the shoreline becomes less accurate, but there is still a perception of how the soils moves. Also, it's interesting to see visually how people are affected by droughts. Seeing in the image on the center, the dots are showing where the people, indigenous people, leaves their boats. And you can see that they have to walk very long distances, particularly for people that lives on the tributaries, to reach a navigational point. So to do trade or go to school to the nearest by city center, it's very impactful. Also, here you can see that there is a good correspondence of the perceived low water in the present with that are compared with the low water frequency map that I showed to you before, to the point where people drawn some of the pools of water that are to be found in the river that goes inside the communities. And yes, overall, there's a very much good correspondence. So to conclude, in this kind of environments where the low water periods, events, and droughts are difficult to monitor due to the data scarcity and the cloud coverage and many factors, it's an integrated analysis could help to provide a more complete overview of the study area. And some perspective for the future research are to better investigate the sediment dynamics, which I did not went much in depth in this study area. And also to, of course, extend the number of interviews, because 17 interviews is quite a limited numbers. Then could be also to reactivate already existing inactive station, and of course to overcome the cloud coverage, to integrate star satellites data, and to be able to have more winter images and also summer images. Thank you for the attention. I don't know if you have any questions or people from home.
So we have a question here. Thank you. I have two questions actually. The first one for professor that work on the catfish is that how decided the personnel from the buildings, the enterprises that manage the dam to do this translocation of the catfish, if they decided spontaneously or if they were in some way forced to do it. So if they took also in consideration these citizen science results. And the second question, I'm curious to know if the people you interviewed, if they were concerned about this changing in elevation of the river patterns, or if they yes, what were they concerned about? Because you talked about concern about health and fishery activities, but in which way they were concerned about taking actions or just starting to acknowledge these changes? So if you can explain a little bit more. Thank you.
Yes, thank you for the question. It's a quite difficult question because it's quite difficult to get information from the companies. It took us a long time. Why? That this has a long history because one of the reasons is that Brazil does not accept environmental impacts in Bolivia. At the same time, for the same reason, the companies are not obliged to provide this information, to make it public. So it is quite difficult to get this information. So that's the first point. No, it took us a long time. Second point is that these companies then within their mitigation strategies foreseen in their environmental impact studies, they are obliged to test the efficiency of their bypasses which they have constructed. So they have done a lot of translocations and movements of fish to see whether the fish pass these bypasses, these translocation systems. And part of this type of testing was the translocation of individuals from downstream to upstream. Luckily, they have done this with their mitigation system, and this provided us with opportunities to test the efficiency of this system to save the species.
So to answer your question, thank you for your question, first of all. So the perception of indigenous people was quite varying, because I interviewed 17 people, which is a quite small sample of people. So there were quite contrasting perception. On one hand, people were like, if they were asked directly, they perceived it as a problem. But I think that historically they have like more of a perception of danger that it's linked to flooding events. So it's something that, for my perception of their perception, it's something that is becoming nowadays a problem. So they're now starting to feel like it's a kind of event that it's much more cruel compared to droughts, to flooding events. And also, in which way, you were asking, their activities are affected, right? So, for example, for the fishing parts, when the level of the water that can reach like 10 meters during winter times events, it can also reach half a meter during drought events. So in this kind of environment, fishes migrates elsewhere where the water it's higher. They were indigenous people, that's what they were telling me. But also for the education, like people have to get up very, very early to not get burned under the sun, because it's very strong, the sun, in this kind of periods where it does not rain. So at 4 a.m. to walk to get to school, and children are much more affected also for the health part, because they are not used to unsanitized water, and sometimes it's not everybody does sanitize the water. And you can get to the Puerto Nariño, which is, depending on where you are located with the communities, you can go there and get there the water, but it's not that easy to walk there and go there every day to get for everything that you need for water. And also for trade, like you have to, because when the river dries up, it becomes navigable just in the parts of the river that have more depth. So they have to find those little parts of the river with the small boats and go around slowly. So to give you an idea. Thank you.
Yes, Davide Vanzo.
Hi, thank you. Can you hear me?
Yeah.
Okay. Thank you to both the speakers. I have actually a question for each, and very interesting presentation. So, first question to Paul. Can you comment a bit if there were other ecological other species that took ecological advance from the creation of the barrier or the reservoir, the hydropower plants? Because I saw one of your graph, I think was Surubi species seems to increase after the creation of the dam. So I was wondering if you can comment what happened at the scale of ecological, let's say, competition, and also if something strange happened in between the two dams, because actually there is almost a new ecosystem forming. And the second question to Camilla is that if you investigate or if you can comment on vegetation dynamics related to droughts. So is there evidence or some hints that also vegetation dynamics are affected there by droughts, and if this could also affect river dynamics? Thank you.
Yeah, thank you very much for this question. The first answer is that the reservoirs of the dams, which are run-of-the-river dams, so the reservoir is not very big, but even then it's quite significant, do not occur in Bolivia. They occur in Brazil. So we actually don't have the permission to go and see what is happening in the reservoirs. Yeah, of course, we know from Brazilian researchers that the impact in these reservoirs is very significant. No, fish communities are changing. Fish do not recognize anymore the reservoirs as part of a normal river, so their swimming patterns are changing. But we ourselves, we do not research in these reservoirs because we cannot do it. Secondly, the basic original question of our monitoring with the fishermen was to see the effects of overfishing. So when we started in '98, the idea was to see what is the impact of overfishing on fish stocks. And then gradually we put in the dam study and so on. So this came afterwards. So the main question which we had, what is the impact of actually 4 factors on fish capture per unit effort? Overfishing, hydrology, the same fishery effort, because the effort in time changes, and then also the dams. So finally we found out that the fluctuations in density of many of these catfish species is mostly influenced by climate and hydrology. So the upstream migration of all these catfish is actually regulated by flooding. So when there is a lot of flooding, the fish leave the lakes and they start to move directly upstream to spawn because they have actually their gonads ready to spawn. So we have seen that the climate and the hydrological factors are the main driver of population fluctuations in time. Overfishing, no. We don't have any reason to think now that overfishing in this area is an important driver, an important factor. Dams, very important, but only for the species which have long distance migrations. As far as we can see now, the dams don't have yet impacts on short term or short distance migrating catfish. I'm sure that at the longer term we can eventually find an effect, but till now we don't see an effect on other species besides the gilded catfish. And of course, there is a strong impact also on fisheries effort. Fisheries effort changes fisheries capture and fisheries capture per unit effort. And that's why certain species after the dams increase in catch per unit effort, because the younger fishermen become more efficient in catching fish because they use more nets, different methods. They learn also from their fathers how to catch fish. So one of the reasons why the catch per unit effort of certain species increases after the dams is because the fishing effort is increasing.
Thank you for your question, Davide. So to answer to you about the effect of drought events on vegetation, the only part where I studied more this kind of effect is on the Meccanica island dynamics that I showed to you before, where you can see the movement, for example, of the islands going from 2019 to 2024. We can see that as the bank becomes much more bigger, the vegetation also grows, and this leads to an accretion of the bank, it seems like it. And so to the narrowing and the movement, like it affects a lot, it seems, for what I saw, the morphology of the island. Then I did not go much more in depth about how drought event affects vegetation specifically. But from what I saw also going on the field, there is an island, a small island, that it's getting bigger in these last years, and it's in front of communities. That it's one of the one that I interviewed, and also it's becoming bigger, and it's becoming more vegetated. But it is also a little bit tricky to connect it to drought events due to the very complex kind of environment that is the Amazon River. So it could be also due to the natural dynamic of the river reach.
Any other question or curiosity for our speakers? Okay, thank you, Massimo.
Well, thank you. Thank you very much. I'm more concerned on Paul because we struggled for months with Camilla, so I don't want to stress you again. Thank you, Paul. My curiosity, first of all, is what is the pace of recovery after your intervention? And considering then you know, according to the GBF, the global planning for biodiversity, the pace of recovery would be 30% by 2030. So if the rate of residual larvae was 10%, if I well understood, what is the state of art today? Secondly, I would like to know your opinion about the completely missing approach in terms of cooperation, international cooperation in the area, not applying, for instance, the international treaty of transboundary waters, because recovering energy from water, it's important for a country like Brazil. But I think that even maintaining the flow in the aquatic corridor in the aquatic ecosystems is so delicate. How is the river basin of Amazon? It's important. So recapping, what is the pace of recovery? And what about, what is your opinion in the missing cooperation among Bolivia and Brazil? Thank you.
Thank you very much. These are very good questions, very difficult questions to answer, because actually, I think we have just finished a stage of research. We now understand what is happening, and I think we have to use in the future more cooperation networks to understand better what is happening and see also eventually mitigation approaches, new mitigation approaches. What we now know is that more or less the population is still relict in the downstream part of the Amazon. I didn't show this, but we also did, or the Frenchmen, because that's not our analysis. They also did microchemistry analysis of otoliths in the downstream part of the population, which are actually the fish, which were born in Puerto Villarreal in the upper stream, and they are still there and they cannot move upstream. We have indication that there is still a population of Madeira fish in the Amazon part in the estuary, which is trying to swim upstream. No, what we need is actually more data on the population status of this part of the population, which is downstream from the dams. Now, we have a lot of different data. We also know now that of the 300 specimens which have been translocated, 12 of them could arrive, which is a low percentage. It's only less than 5%. So, but this gives us a lot of information on how is the fisheries mortality and how is the natural mortality. So we can now, on the basis of the action plan which was approved during the COP, actually design an approach which allows us to not recover the population because it's still there, but to keep the population at the basic level till there are certain agreements with Brazil to improve their bypasses. Because that's something which I did not explain in a lot of detail. The Santo Antonio Dam has a bypass system, but it doesn't work. The Girau Dam does not have a bypass system. They don't have a system to translocate fish. They only do it manually. So we hope that on the basis of all these results, the Brazilian companies will improve their bypass systems, that they improve their research and so on, which will be very expensive to improve the translocation naturally or manually of these individuals. So that's why I talked about a short-term solution and a long-term solution. Of course, the long-term solution is a solution which includes the answers to your second question. Till now, we only did bilateral cooperation and collaboration between Bolivia and Brazil, which actually has not advancing a lot. No? Now that the COP15 has approved an international action plan, I think we have room and space and opportunities to include also more countries and to have transboundary agreements, also including Peru, for example, because part of the Madeira Basin is within Peru. So on the basis of the very general action plan, which was approved in the COP recently, last month, we are already now designing very rapidly an action plan specifically for the Madeira Basin, which, for example, includes translocating more fish individuals, tag these fish so that we know when they have been born and how they migrate, and also include all the fishermen in Bolivia and Peru such that they do not fish or kill the individuals but return them to the river. So to be sure that these fish can keep on to spawn. No? For example, the individual which I showed, which they have fished 2 days ago, this was actually fished in an area where there is already an agreement for a fishing stop on this species. But it doesn't work yet very well because the local government did not have yet an official law which obliges the fishermen to return the individuals. And there also is not yet a compensation system for these fishermen which they eventually could profit from to have a compensation in terms of money for the fish which they have to return to the water. So there is still a lot of work to do, and we need a lot of transboundary cooperation for this incredible catfish species, because there is not another freshwater species which migrates that long distances. So I think it's an obligation of all of us to protect this species and to save it. No, so I think we need a lot of work together in the future.
Okay, so no more questions, curiosities. So we can close. I would like to thank very, very much the two speakers that accepted the invitation to share their works here today. So thank you very, very much for your presentations, and thank you all for being here and to have participated. I would like to remind some few things to the students who would like to receive the credit F, that there is the attendance sheet at the exit. And then you can find the information about the past and upcoming webinars on the Moodle. Today's seminars slide will be uploaded in the next days. And If you have any question, you can contact us by mail. We have the website of the UNESCO chair that you can visit, and also the YouTube channel. So finally, I would like to remind you our next seminar, which will take place next Thursday here, same place, same time, April 23rd. Entitled Planning for Transformative Change with Nature-Based Solutions. So thank you again, and have a great evening. Cosa? Sì. Ah no. Sì. Che vedo che ho scritto. Proviamo a lanciare queste cose nelle prossime settimane, perché c'è per cogliere questo. Aspetta, esco qua. Perché vi chiedo